Okay, tonight we're going to be looking at 2.3, which is conditional statements. This really is introducing us into proofs, into how to read theorems, which we're going to be doing for the rest of geometry. So it's very important that we learn it. So a conditional statement is just an if-then statement. An if-then statement. Okay? With a conditional, the hypothesis follows the if. Okay. The conclusion of a conditional follows the then. So if you're reading a conditional statement, it should read if hypothesis then whatever your conclusion is. Okay, so if hypothesis, then conclusion. Also have some notation for this as well. That's important to know. P, sometimes you'll see that. That stands for the hypothesis. And Q stands for conclusion. So you'll see that with your book, and I'll use it sometimes, so it's important to know. So if you're writing a conditional in terms of symbols, you would say P, then Q. Okay, that means if P, then Q. Alright, so you'll see that notation a lot. Okay, so let's look at the following statements. We want to identify the hypothesis and the conclusion. So the first one says, if the measure of angle A is 15, then angle A is acute. That is a true statement because an acute angle is in between 0 and 90. So the hypothesis follows the if. So the hypothesis is measure of angle A equals 15. That is the hypothesis. You can also just write that is your P. It's the P of your statement. Notice I don't include the word if here. Okay, so the hypothesis follows the if. The if is not part of it. The conclusion would be A is acute. What follows the then? That's your conclusion or your Q. Alright, let's look at this next statement. Again, we have if angle 3 and 4 are vertical angles, then angle 3 is congruent to angle 4. That is also a true statement. So our hypothesis is 3 and 4 are vertical angles. And I'm just going to put a P here. The conclusion follows the then. So it is angle 3 is congruent to angle 4. That is your Q. Okay. Alright, given this following statement, we want to see if we can write it as a conditional. Remember, that just means I want to put it in if-then form. So I need a first part and a second part, a hypothesis and a conclusion. So let's look at the following statement. A square is a parallelogram. So the first part seems to be saying something about a square, so we can make that part of our hypothesis. The second part seems to be saying something about being a parallelogram. So that can be our conclusion. So it would sound kind of funny if we just said, if a square, then a parallelogram. So we might need to add a little words just so it sounds good as a sentence. Okay? So how about if a figure is a square? Or you could say a shape is a square. So sometimes you may have to add a few words in there to make it sound good. Then it is a parallelogram. Now, if you stated yours a little bit differently, that is okay, as long as the first part has something about being a square, the second part has something about being a parallelogram. Okay, so you can see we're still using square in our hypothesis, we're still using parallelogram in our conclusion. We just added a few words to make it sound good. Alright, now we want to look at this one and write it as a conditional statement. So this says, adjacent angles share a common vertex and side. So the hypothesis is that we have adjacent angles, so that can be our P. The conclusion seems to be that they share a common vertex and side. Okay, that seems to be our Q, our conclusion. So we can say if, how many angles does it take to be adjacent angles? Well, it takes 2. So we can say if 2 angles are adjacent angles, then they share a common vertex and side. Okay, so that is just writing it as a conditional. So the next thing I want to look at is just a definition of a word. That word is negation. Negation is simply writing the opposite of a statement. Negation is the opposite. So a lot of times negation looks like putting a not in front of something or a does not in front of something. That usually is what negation is going to look like for us. So let's look at the first statement, and we want to negate this. So it says the measure of angle A equals 52. So the opposite of the statement would be that the measure of angle A does not equal 52. Okay, this symbol just means does not equal. In case you haven't seen that before. Does not equal. Okay, so that statement is negated. Let's look at the second one. Today is Tuesday. Well, let's think about this. If we say today is Wednesday, that isn't the complete opposite of that statement. So we have to say today is not Tuesday. Have to make sure you're getting the complete opposite here. Today is not Tuesday. Alright, that is negation. So now we're going to look at different types of conditional statements, and we'll have to use negation in some of them. Alright, let's look at the first one, the converse of a statement. The converse simply switches the hypothesis and conclusion of a conditional. So instead of writing P then Q, for a converse, you're going to write Q then P. You'll put the conclusion first. So let's look at the following statement. It says, if a polygon has 8 sides, then it is an octagon. So this first part is our hypothesis. The second part is our conclusion. So converse says that we have to switch those. So the converse of the statement would read, if, and then we would state the conclusion. A figure is an octagon. Notice I added a few words in there to make it sound good. Then, and now we can state the hypothesis. It has 8 sides. Oops. or it is a polygon with 8 sides. Either one of those would sound good. So that is the converse. I simply switch the hypothesis and conclusion. Next one is the inverse. For an inverse, I negate the hypothesis and conclusion. So this is the same one we just used. We already identified our hypothesis and our conclusion. Alright, so if we're negating the hypothesis and conclusion, the notation for that is going to say not P, then not Q. So this little squiggle here just means not. Okay, it's the negation of something. So let's see if we can write our conditional, the inverse of our conditional. So the hypothesis says if a polygon has 8 sides. So the negation of that would be if a polygon does not have 8 sides. So if a polygon does not have 8 sides. And now we can negate our conclusion. Then it is not an octagon. Okay, that is the inverse of that statement. Next, we're going to look at the contrapositive, and this one is last. For a contrapositive, we switch and negate the hypothesis and conclusion. So we switch the places, and then we add not to each of those. So the way that we would symbolize that would be not Q, then not P. And if you learn the symbols for these, it will help you when you're writing them. So contrapositive, switch, and also negate. So let's look at this one again. We got our hypothesis, we got our conclusion. So we could say if, so we need to say not conclusion. So if a figure is not an octagon, or a polygon is not an octagon, then, so now we negate the hypothesis. It does not have 8 sides. Okay. One last thing that we'll also be doing with these is determining the truth value of these statements. The truth value. That is the statement true or is it false? And we have to look at each and every statement to determine that. So just because the conditional is true doesn't mean that the converse, inverse, and contrapositive will be true. So the truth value just means, is it true or is it false? So let's look at this contrapositive. If a figure is not an octagon, then it does not have 8 sides. Well, that is a true statement. That will always be true. And if you can find even one case where it's false, then it is false. Okay, that is a counterexample. It proves what we're saying is wrong. So here's a little table I thought would be helpful to you that just lists out the conditional, converse, inverse, and contrapositive and what they are. I'm going to add the symbols into that real quick. So conditional is if P then Q. Converse is if Q then P. Inverse is if not P then not Q. And a contrapositive is if not Q then not P. And remember, for each and every one, you're going to need to determine the truth value. So the last thing I want you to do is complete this try it, pause the video, See if you can write the converse, inverse, and contrapositive using your notes, and then when you unpause it, I'll have those answers up for you. Okay, so here is the answers to that try it problem. The converse would be, if an angle is acute, then it measures 80. That is going to be false. Sometimes it can measure 80, but anything between 0 and 90 is an acute angle. So for my counterexample, I just put 45 as acute, because if it is false in even one case, it's a false conditional. Alright, let's look at the inverse. If an angle does not measure 80, then it is not acute. False for the exact same reason. Anything from 0 to in between 0 and 90 is an acute angle. And then the last one, the contrapositive. If an angle is not acute, then it does not measure 80. That is true. If it's not an acute angle, it can't measure 80 because 80 is an acute angle. Alright, so I hope that this went well for you. I know that it is a lot of writing, but we'll come in tomorrow, go over any questions you might have, and get to work.